For this lesson, let's take a look at the area of some combined polygons. For example, let's take a look at a polygon that looks something like this. If we label the sides of it, we're going to give it centimeters. And we're going to make these right angles. So here's this polygon, and we can tell by looking, we've got this angle coming down. Looks like it's to be a hypotenuse. We can probably imagine pretty easily this is going to form a triangle. With the sides that we're given, we know that the height of the triangle, by associating this side here with that side there, we know the height is going to be 4 centimeters. And since this length over here is 6 and this entire length is 8, we can come to the conclusion that from here to here is going to be 2 centimeters, because that is the difference of the two sides. So if we were to take this apart, we have a rectangle now that is 6 by 4, and we have a triangle that looks to be 4 by 2. So we need to use two different formulas. We need to use area equals base times height for a rectangle, and the area equals base times height divided by 2 for our triangle. We substitute in 6 and 4. So the area of the rectangle, we're looking at 24 centimeters squared here. For our triangle, we're looking at the area is 2 times 4 divided by 2. That gives us 8 over 2. So we're looking at 4 centimeters squared for the triangle. So then we need to add these together because these were combined figures for the polygon. So we then have 4 centimeters squared plus the 24 centimeters squared gives us a total of 28 centimeters squared for our polygon. So this total polygon here is 28 centimeters squared. So let's take a look at a slightly more complex combined polygon. Okay, so we're looking at this figure now. In the figure AD here is 40 centimeters, DC is 30 centimeters. Point B is the midpoint of segment AC, despite what it looks like, and point E is the midpoint of AD. So what we have is a pair of similar triangles, and we're looking at some segments, and we need to find the perimeter of quadrilateral BCDE. So the one we're looking for is right here. We need to find its perimeter. So let's look at what we got. If we pull out the larger triangle, make a quick sketch of it, we know that AD is 40 centimeters. We're also told that DC is 30 centimeters. Point B we know is here, it's midway. And point E is here, and it's midway. We're looking for the perimeter of this figure, roughly. And right now all we have is 30 centimeters, and we know we have the 20 centimeters because 40, half of that, is going to be 20 and 20. So we've got two of the sides we need. If we pull out the smaller triangle, because we're going to need the smaller triangle as well here, what do we have on the smaller triangle? Well, we know we have A, E, and B, and we know we have 20 centimeters here. Well, what we need to find is this. That's the next step. And we know we can find that by setting up a ratio box, because we have a side here that we can relate to this side here. So we set up a ratio box. And over here I'm going to put triangle ACD. Over here I'm going to put triangle ABE. This is going to be my longer leg. This is going to be my shorter leg. My longer leg for ACD was 40. My shorter leg right here was 30. For triangle ABE, I know the longer leg is 20. Looking for the shorter leg. Now I can cross multiply and divide. Let's set up the equation. 40x equals 20 times 30. So 40x equals 20 and 30, 600. Divided by 40. So x is going to be 15. So I know this side is 15. Could also apply the idea of scale factor. 40 to 20, 30 to 15. Scale factor is 1/2 in this case. But this helps in the fact that now I know that EB is 15. Now, that still leaves us with the question of what is the length of AC? Well, there's a couple different ways. We talked about right triangles and having relationships such as 3, 4, 5 for their side lengths. Well, we can apply that here. So I have 3, 4, the other side, you guessed it, be 5. We're adding a 0, so AC has to be 50. I could also apply the Pythagorean theorem and do 30 squared plus 40 squared equals c squared. Well, 30 squared is going to be 900. 40 squared, we're looking at 1600, and that equals c squared. Add them together, we get 2500 equals c squared. Square root of both sides to solve. 50 equals c. Still get the same answer, but AC is going to be 50. And since AC is 50, we know half of that is 25 each, because B is the midpoint right here. So AB is 25, BC is 25. So now to find the perimeter of a quadrilateral BCDE, we're going to add 30 plus 20 plus 25 plus 15. 30 and 20 gives me 50. 25 and 15 gives me 40. 90 centimeters is the perimeter of the quadrilateral BCDE. So perimeter BCDE equals 90 centimeters. And that would be our final answer. So as you can see, a lot of work going into a problem like this one. A lot of things to break down. And we could have, if we found the 25 centimeters first, because I could have done this in a slightly different order, I could have found the 25 centimeters first here using the Pythagorean theorem or the 3-4-5 relationship on a triangle here. I could have found this first, then used the Pythagorean theorem to find x over here, and not even used a ratio box. But I went with the ratio box because I had that relationship. Also, the idea of scale factoring can be applied. So, lots of ways to solve a problem such as this one. Big thing is, make sure you're showing all your steps, show all your work, and work all the way through it, because there is a lot of calculation to do on a problem like this one. Good luck.